Working now? Hello? All good? How's that? Is it going? All good. Hi, everybody. Is there a chance I can get a PowerPoint here? Like that. I've got to hold it. All right. I feel like a rock star now. Is there a chance I can get a PowerPoint here?
You want a plough plug? Is there any down there?
No. It's all right. I'll leave it out. It's okay. If I get a PowerPoint in time, I'll do just a little demo of this. So some time ago, I've said a couple of times that Ethernet over IP is my best friend. Somebody shouted out to me that that's just a little bit sad. So now I just say it's fun. Although this morning at registration time, I did meet somebody who admitted to me that EOIP was also their friend. Didn't quite say it like that, but me being a fan, I'll accept it that way. So just a bit of context for what I'm about to talk about. I'm from DuxTel. We're the largest distributor in Australia and Pacific area. You might have guessed where I'm from by the way I speak. I speak normally, actually, from where I'm from. Something I've already noticed too is you guys say router. We try to avoid that pronunciation. We call them router, like other places, because router is just a little bit amusing to Aussies. So we're a specialist in solution providers, solutions for ISPs and WISPs, and any internet kind of infrastructure. So we have customers who do apartment buildings, student accommodation, so forth. And we also do free nets, so for city districts who want to give free Wi-Fi to visitors and tourists and so forth. We offer hardware solutions and software for that. And all throughout Australia. So we're fairly, I guess, spread out in Down Under. And so often the actual installations are a long way away. But just quickly an introduction about Ethernet over IP. So it is a GRE tunnel, but it's not just a GRE tunnel. It does some really cool stuff. Like for starters, it carries Ethernet frames, full frames, and so you can bridge it to other types of interfaces, even physical ones. You can route across it. You can use it in firewall rules. You can NAT, queue it, bond it. You can do all kinds of stuff that you can't do, or you can't do very easily with other kind of tunnels. There are some limitations. One of the obvious ones is that it doesn't play with NAT very well, because to make it work properly, you do need to have routable addresses on both sides. It is, I've got listed here that it's proprietary MikroTik. Well, it's not exactly, but for quite some time it was only Router OS that supported Ethernet over IP. But just lately there's been some other, especially the Linux type routing systems also implemented. OpenWRT, for example, I believe now has a implementation of Ethernet over IP. Another thing that's a bit of a gotcha is that the MTU can often get screwed up because if you're running it especially over things like PPP or PPTP tunnels, then the frames are going to get squished down a bit, and when you try to bridge them to other interfaces that have full-size frames, then things can go strange. Just something to look out for. The tunnel ID 65,000 is probably enough, but it can run out if you're using lots of them. And so the first example then of how I'm using it, I'm going to talk about two particular uses. There's many. I use it very often, all the time. And these two are probably the most interesting and useful and time-saving. So two routers. Oh, so this is the setup. It's very quick to set up. So you just really need two addresses, the two endpoints and a tunnel ID. So here's the first example. So the city of Horsham, the blue box in the large-scale map is an indication of where we're looking. So the city of Horsham's 285 kilometres away. It's a 3.5-hour drive. So if something happens and our contact in the city calls us up and reports that there's something strange happening on that particular hotspot, when we log in through Winbox and have a look at everything, it sort of all looks okay, and it's kind of really difficult to figure out exactly what's happening. One way to diagnose further would be to send someone down there and start doing some diagnostics while we're watching Torch Tool and that kind of thing. But having someone actually out and about is a bit different. It would be a whole lot easier if we could just hook up a client PC to that hotspot cell locally and run the diagnostics ourselves. So using Ethernet over IP, we can do just that. And this is how it works. So this is just a quick dude map of the way the network operates. Is there a laser pointer or something around here? No, it's a BYO setup. So there's a couple of gateways in this network. Up here we've got the main internet connection and just some wireless infrastructure with on the ends here are the hotspots. So there's the gateways. These are the hotspots, and all those hotspots connect back to the nearest gateways with a PPPoE. That's all layer 2 network there. So that each of those gateways offers the IP address to the hotspots. Thank you. This one. Okay, thanks. So we've got all these EOIP tunnels. There's also a couple of demo hotspots that we use to carry around and show off at various places, especially for demonstrating to potential clients and so forth. And they connect up using a PPTP VPN, and they sort of operate kind of the same way. So what we can do with these is we can essentially build an Ethernet over IP tunnel in between the two. So if, let's say someone reports here, for example, that when they access the captive portal page down here, so the Google map that's supposed to show whereabouts you are here kind of thing, maybe that doesn't display. And yet looking in the router OS and trying to figure out what's wrong with the cat-walled garden entries or something like that, it's difficult. So what we can do is we can essentially put a tunnel in between, and then when accessing the wireless here, or Ethernet for that matter, we can make a client connected here appear to be actually connected to this device. This is how it looks like in just a diagram. So we have here is the router on the hotspot network. The way that these configs work is there's a bridge inside it that's connected to the wireless, and the hotspot actually runs on the bridge. Then has an Ether network, and this is where the PPP tunnel comes in, PPPoE. So the first thing to do essentially is to build an Ethernet over IP tunnel in between. All we need to know is the addresses of the two endpoints, which we have by virtue of the the VPN addresses. We then add this end of the tunnel to the hotspot bridge, and over here we introduce a new bridge also, and then we connect that this wireless interface, or maybe another Ethernet if we want to, onto there. So we end up with essentially this wireless connected straight through to this wireless. Which means, of course, that when a client connects to this, it's going to get an IP address from here. It's going to route out through the remote gateway, and it's going to get all of the captive portal hotspot type activities from that remote end. This is where I was going to do a little demo of that. This diagram here shows the remote hotspot, so the hotspot sitting on a pole out in that country town. It has an Ethernet tunnel. This here shows the bridge ports, and we can see here that the Ethernet tunnel is actually connected into what's called hotspot bridge, which is the bridge structure that runs the captive portal hotspot and so forth, CP server and so on. Ah, it is connected. Thanks, whoever did that. So on this one, this is actually one of those PPTP remotes. Of course, I don't have an internet connection on it. So what I was going to do with this one, is essentially demonstrate how it's set up at the moment, pretty much the same way, is that it has a hotspot bridge, and the hotspot bridge connects the wireless and other Ethernet-enabled, or Ethernet captive portal Ethernet sockets. And then all I have to do is I create a new bridge in here called tunnel bridge or something like that, and then I just switch the WLAN over into the tunnel bridge and connect the Ethernet tunnel on the local end. Then all of a sudden, when connecting to the bridged hotspot or the remote tunnelled hotspot, you can connect and you'd see the login page of the remote with the map showing you exactly where it is. Or if there is no map, because if that was the issue that was coming up, we can then actually do some web requests and some pings and some DNS lookups and run Torch tool and figure out exactly what is going on. Example number 2, this is something that happens quite often, especially out in country remote areas where there's quite a lack of internet infrastructure. And as we know, the speed of any access to internet really comes down to the weakest link. In Australia, we have a fairly heavy use of ADSL as a customer access network. Seems like we're one of the few places that has such a thing, and being spread out, sometimes those last mile links might be right at the limits of ADSL usability. And not only that, the copper is all pretty rubbish, and it sits in the ground and it turns into green jelly very easily. So in many places, in fact, we even have still to this date, we still have internet services that just stop working when it rains. And when they're working really well, then we might have a service that gives us perhaps 1 or 2 megabits download and maybe half a meg up, if we're lucky. So the obvious solution is just to put many of them in place. Just stack up the ADSLs and gives us more access. The obvious downside of that is that we can distribute the load, but because of the way that these work, they're all independent. And another thing, in Australia, most ISPs refuse to support multi-link PPP. So it's not possible to aggregate. So you end up having to load balance by connection, and then the fastest you can get for any single stream is just going to be limited to the service that's actually in use. Not only that, but anyone who does load balancing like this will also know that it's almost impossible to get an even distribution. And so quite often, if you analyse it for long enough, you'll find that one of the links might be used really heavily, even though another one is fairly easy going and plenty of capacity. So wouldn't it be good if you could aggregate all of those ADSL links? Thanks to Ethernet over IP, you can do just that. And I'll just give a discussion or description of how that goes by using just 2 links to start with. So here we have 2 modems. They're bridged and they're connected to a 2011 router. So the PPPoE clients are running on the router to the ISP. We don't care too much about what's on this end because they're just bridged. Oh, and of course in the cloud here, in some data centre with a nice heavy-duty link to internet, we have another MikroTik. Of course, the whole deal with Ethernet over IP is you need 2 ends of it. So it does need a cloud-side router, which could be CHR for that matter, or any kind of Ethernet over IP support. So next thing to do is lay down some tunnels. So we make an Ethernet over IP tunnel, one across each of those. And the thing we need to watch out for is because each of these addresses are coming from the ISP, we need to have both endpoints, and we need to make sure that traffic over the particular Ethernet tunnel is going to run across independently of those. So we just need to set up a couple of routes. So this one here, for example, we say this tunnel must always go across this link. Of course, another cool thing about Router OS is that for gateway we don't need to specify the remote address. We can actually specify when it's PPP the interface. And this is really handy in this situation, of course, because otherwise the endpoint or the PPP server may very well be the same for both of them. So by defining the interface name as the gateway, we can make sure that that will always traverse there, and this will always go to there. So this router here, of course, just got 2 different interfaces, 2 different addresses on the same endpoint interface. Next thing we do is just make the tunnels, and as mentioned before, it's really easy to do. You just need the local and remote addresses and a tunnel ID, and it's done. As far as return packets go, we don't really have to worry about that because the ISP has already set it. And then once we've got these 2 tunnels, it's just a matter of bonding them together using the interface bonding of Router OS. And we end up then with a single aggregate link that looks like this in concept, logically. And that way all of the traffic is aggregated across. So if we had, say, 10 ADSL links giving us 1 megabit each, then we can get the aggregate over a single stream. Like so. The catch of this is that with bonding, you may be aware it's actually limited to a multiple of the slowest one because of round-robin type packet routing, so that if you have one Ethernet, or so one internet service that's 1 megabit and 2 internet services of 10 megabits, then you're really only going to get a 3 megabit aggregate, which is kind of counterproductive because of the slowest one is going to hold up everything. Might just have a quick look at the interface bonding. It's on the other side, isn't it? Wonderful. So with the setup I was talking about before, this shows the WLAN 1 connected to the public hotspot bridge there, and to flip it over, we just need to, it's just as simple as one click. That would set it up as like that remote slave. For interface bonding, if you haven't seen it before, it's just in Interfaces menu, and then Bonding. Click to create a new interface. And then just add the Ethernet tunnels. Ethernet tunnel 1, tunnel 2, tunnel 3, and so forth. Add as many as you like. Once that bonding interface is created, then it's just like another virtual interface in Router OS. So it has, you can put addresses on it, you can NAT on it, you can firewall on it, you can do all that kind of stuff. That brings me to the end of that introduction to Ethernet over IP. Certainly is a very versatile feature of Router OS and something that can do some great things. So even just the availability to do that sort of diagnostic to a router that's 3.5 hours away is a great thing. Makes you feel like you're there. In fact, it could even be on the other side of the world, if I could set up the demo properly. Sorry about that. This is just a bit more background about DuxTel. We do have some sample scripts on our website that are available for free, which demonstrate various different things. Anyone have any questions? Okay. Ready for an early lunch then? Yes.
I just had a question. You got
Sure.
Ethernet
ADSL lines?
ADSL, yep, or DSL. It can be any kind of thing, really.
ADSL, you know, it can degrade, can't it, especially with the high resistant joints to the ground, etc.
Absolutely.
Error correction thing goes on.
Yeah, yeah.
How does that translate through to your bonded Ethernet layer?
Yeah. The DSL lines have to be pretty good, and they have to have very similar latency. They have to be, it's best when they're about the same rates, but generally in I guess the best results that we've seen have been about 80% of the theoretical aggregate, and sometimes as low as 50%. So it can get, the aggregation result can be very low, but you know, if you're going to have 4 of them to give you about double the aggregate, then it's still often a plus.
But what about if you've got one that's got a degradation problem? How does that affect the overall Ethernet bundle?
Yeah, well, once again, the aggregates will be a multiple of the weakest, of the slowest. So if one of them degradates down to 200 kilobits, then and you've got 5 links, then you're only going to get 5 times 200. So in those cases, it can drag things right down really slowly. So it certainly doesn't work well in all cases, but when there's no other option, it's certainly one to try. Yeah. Yes.
In the bonding scenario, if one of the links disappears, does the link Ethernet over IP keep running? Or?
Yes, bonding generally will fail over. So if one of the links goes out, then it will detect that loss with the LACP. So your link aggregation tests will recognise if a link has become unavailable, and it'll distribute across the remaining. Yep. Yep.
How does package reassembly work when the packets arrive out of order?
Which is why you need to try to get links with similar latency. Essentially what can happen is that the queues fill up, right? So your interface queues fill up and you just start dropping packets. So you can, I guess you can overcome that a little bit by bumping up the queue size. But if they're that far out of sync latency-wise, then you're never going to get a good result anyway.
The reason why I'm asking this is because of, in the Netherlands, many companies start working in the cloud. So they're using RDP connections, they're using VoIP across these connections, and I can only think about what will happen if packets arrive out of sync.
Yeah. Yeah, look, real-time traffic, you're going to have trouble over a single dodgy link. If you're going to have multiple dodgy links, then you're going to aggregate your problems as well, I suppose. But look, it's like I say, it's not an ideal solution, but in situations where you don't really have any choices, it's something worth trying. And I've seen some very astounding results, some very, very good successes. So that's, but you're right, there's problems with latency and so forth. Yep.
I'm just wondering if you've experimented with different bonding types. I noticed in your configuration there you're using round robin.
Yeah.
Have you used LACP, and what differences do you find with different bonding types?
It's going to depend on the quality of the links, once again. Generally with anything other than just pure Ethernet bonding, it's going to be a suck it and see, I guess, as we say in Australia. Give it a try, see how it goes, run it, try and understand, I guess, why the limitations you're seeing are there, and have a look at some of the options. But I guess the bottom line there is that the bonding feature will work just as well on the Ethernet over IP as it will work on anything else, because the EOIP is Ethernet frames, so you can choose pretty much any one of those options that you like.
Sorry, just to come back on that.
Bonding types? Yep.
Anything other than round robin will balance either by MAC or IP address. So any stream will use
Okay.
Which link it goes on.
All right. Okay.
The stream will only use one link.
Okay. Thanks. So if you didn't hear, the comment was that the other than round robin bonding methods are going to multiplex on the MAC addresses anyhow by stream. I think, is that what you're saying?
It's either MAC address or IP address and or port. So
Okay.
it will use a property of the stream.
All right.
to pick the link.
Okay. Okay, so the suggestion there is that only the round robin will give you the aggregate. Others will end up in a similar to a load balance by PCQ or something like that, PCC. Thanks. Good answer. Yes.
You spoke earlier about MTU. Could you just
Yep.
clarify, if you've got an Ethernet over
Oh.
IP tunnel,
Yep.
MTU of 1500 are both there?
Yes.
Are you saying you can put that over a PPPoE MTU of, say, 1492 and it automatically would assemble?
No, that's right. Yeah, I'm suggesting the opposite. That if you try to run a 1500 byte Ethernet over IP tunnel over, say, a PPTP link, for example, then you're going to lose bits of it. So what you need to do then is on the bridges is bring the MTU down, which will bring all of the other interfaces in those bridges to small enough so it's going to fit across the remote tunnels. Yeah. Great questions. Yes?
Is it possible to run multi-link PDP over the individual EOIP links?
Yes?
And that would fix the MTU problem?
Yes. Tunnels in tunnels in tunnels. I like it. So the suggestion there was to create your bonded multiple Ethernet over IP bonded link and then run PPPoE over those in a, I guess, LAC kind of LNS type setup. And yep, then you get your streams that way.
You'd get proper balancing across the links, and you'd get like any MTU users.
Perhaps not, because if the bonding methods are using MAC address for the multi-link calculations, for the balancing calculations, then the PPP packets will be constrained to that as well. Nice idea, though. Yeah. Nice idea.
Try it.
It doesn't have an internet connection. It did when I ran the demo upstairs before. I didn't think of that. Yep.
So you have to have an underlying transport method like VPN before you can implement Ethernet over IP. You can't implement Ethernet over IP.
Yes, because it's just a GRE tunnel, so it only has IP addresses. It doesn't have ports, so you need to route it. You need to be routable on both ends. So if, for example, your ISP does NAT from a public address, for example, then you need to put down a PPTP to the other end first, and then run the tunnel over the top of that, because you need to have both addresses arrive in both directions unaltered.
Any particular VPN type method for Ethernet over IP, is it?
To carry the Ethernet over IP, it doesn't. No, you could.
So you can use any of the three protocols.
Yeah, you don't need VPN at all. If you've got routable addresses, if you've got a routed path between both ends, then you don't need any.
And the security within, you not need to implement VPN to provide secure that.
There is Sergey. The Ethernet over IP has a security layer on it now. Yeah, it does. Yeah, that came in just recently, I think. So yes, Ethernet over IP has a security layer on it, so you can encrypt the tunnels. No more questions? Thanks for those questions. Thanks for listening to me. And thanks for putting the weather on. I came here, I stepped off the plane yesterday, And believe it or not, the day was almost exactly the same as when I stepped out of my home about 26 hours earlier. And it's wonderful. So thanks very much.
All right, there is time for lunch. Lunch will be near the registration, so if you have a red ticket, give it to the person who might be standing there. And we will be back at 2:15, and we will have more presentations.